Facial expression spotting, a crucial aspect of nonverbal communication, involves identifying periods of facial expressions in videos. Despite progress in developing efficient algorithms, challenges persist, particularly in detecting subtle motions in micro-expressions and distinguishing between macro and micro-expressions. This paper proposes an efficient framework for facial expression spotting, addressing these challenges through a three-component framework. The framework consists of a sliding window-based multi-resolution optical flow (SW-MRO) feature, which amplifies motion information while mitigating head movement problems. The window length is tailored to perceive complete micro-expressions and distinguish between macro and micro-expressions. SpotFormer, a multi-scale spatio-temporal transformer, is introduced to capture spatial relationships and temporal variations among different facial parts across frames from the SW-MRO features. SpotFormer employs a facial local graph pooling (FLGP) operation to extract multi-scale facial spatial features and learning-based temporal downsampling to extract multi-scale temporal features. The framework also introduces supervised contrastive learning to learn a finer discriminative feature representation for effective differentiation of various expression types. This approach establishes contrasts between macro-expression and micro-expression frames, as well as between micro-expression frames and neutral frames, to acquire more discriminative feature representations. The proposed framework is evaluated on SAMM-LV and CAS, two datasets, outperforming state-of-the-art models, particularly in micro-expression spotting. The framework's effectiveness is attributed to the novel SW-MRO feature, SpotFormer, and supervised contrastive learning. The paper provides a comprehensive overview and comparison of related literature, particularly with regard to temporal action localization. The framework is designed to detect all potential macro and micro-expression intervals within a video, spotting the onset and offset frames, as well as assigning the expression type for each interval. The proposed SpotFormer model is designed for accurate frame-level probability estimation in facial expression spotting, utilizing a compact sliding window of optical flow features as input. The model processes these features through graph node embedding, temporal positional embedding, spatial facial embedding, and multi-scale spatio-temporal attention. The graph node embedding step embeds each patch into d dimensions using a trainable linear projection, while the temporal positional embedding step retains temporal positional information using learnable parameters. The spatial facial embedding step introduces learnable facial part tokens to the graph nodes, enabling the model to understand the overall spatial facial structure. The multi-scale spatio-temporal attention block extracts both coarse and fine feature representations across different scales, consisting of a spatial graph attention layer, a temporal node attention layer, and a multi-scale feature learning module. The model architecture simultaneously models spatio-temporal relations, employing a spatial graph attention layer followed by a temporal node attention layer in each spatio-temporal attention block. The model aggregates information through spatial and temporal downsampling to generate high-level features, which are then used to generate a probability map corresponding to each frame using a fully connected layer. The model is optimized using focal loss as the optimization method, with supervised contrastive learning introduced to minimize the divergence between predicted class probabilities and ground truth class labels. This approach is particularly useful for distinguishing between micro-expressions and macro-expressions near the boundary. The authors evaluate their method on two datasets, SAMM-LV and CAS, (2), achieving significant improvements in overall performance, particularly in micro-expression spotting. An ablation study demonstrates the effectiveness of the proposed modules, including the use of sliding window-based multi-resolution optical flow features and facial local graph pooling operation for multi-scale spatial feature learning. The proposed model, SpotFormer, is a multi-scale spatio-temporal architecture designed for facial expression spotting. It has been validated through a comprehensive comparison of multiple model architectures, including Seq-ST, Parallel-ST, and Simul-TS. The experimental results demonstrate that SpotFormer, Simul-ST, achieves the best overall performance on the SAMM-LV and CAS, 2 datasets, attributed to its ability to simultaneously learn spatial and temporal information. The study also explores the impact of temporal window size on the model's performance, with a temporal window size of 17 frames being optimal for accurately evaluating one frame. Furthermore, the introduction of supervised contrastive learning is investigated, showing an improvement of 6.0%, 16.3% on the SAMM-LV and CAS, ME. 2 datasets with an optimal hyperparameter lambda value of 0.005. The paper presents a novel framework for facial expression spotting, FEs, that leverages a SW-MRO feature to magnify motion information and alleviate head movement issues. This feature is designed to perceive complete micro-expressions and discern differences between macro-expressions and micro-expressions. The authors also introduce SpotFormer, a graph-based transformer that learns multi-scale spatio-temporal relationships from SW-MRO features for frame-level probability estimation. In SpotFormer, they propose FLGP operations for downsampling facial graph structured data to achieve multi-scale spatial feature fusion. Additionally, supervised contrastive learning is integrated into SpotFormer to enhance the discriminability between different types of expressions. The proposed framework is evaluated on the SAMM-LV and CAS, ME. 2 datasets, demonstrating its effectiveness in micro-expression spotting. The results show that the model achieves a recall rate of approximately 0.5 in macro-expression spotting and 0.4 in micro-expression spotting, with an exception for micro-expression spotting on the CAS, ME. 2 dataset where it achieves a high precision score but a low recall score due to data scarcity and imbalance. Qualitative results are also provided, showcasing both ground truth expression intervals and detected expression proposals to demonstrate the effectiveness of the model. The paper concludes by discussing limitations, such as performance under conditions with fewer available micro-expressions, and outlines future work aimed at exploring more efficient methods for extracting robust motion features and developing an end-to-end framework for FEs. The authors present a comprehensive review of existing literature on facial action unit-based deep learning frameworks for spotting macro and micro expressions in long video sequences. They discuss various approaches, including attention mechanisms, transformers, and contrastive learning, highlighting the importance of post-processing techniques for temporal action detection. The literature review covers topics such as facial landmark detection, motion estimation, and action recognition, including the use of spatial temporal specialized transformers for skeleton-based action recognition and feature pyramid networks for object detection. The authors also overview various datasets used for facial expression analysis and video understanding, including the CAS, ME. 2 database and the SAMM-LV videos dataset. They mention the use of decoupled weight decay regularization and principal component analysis for dimensionality reduction. The authors' research interests and backgrounds are presented, showcasing their expertise in facial expression analysis, video understanding, neural networks, machine learning, and computer vision. The authors' comprehensive review provides a solid foundation for their research, highlighting the complexity and nuance of this research area. Their discussion of various techniques and datasets underscores the challenges of facial action unit-based deep learning frameworks for spotting macro and micro expressions in long video sequences. The authors' expertise and research backgrounds suggest they are well equipped to tackle these challenges. The review sets the stage for their proposed approach, which aims to address the limitations and gaps in existing literature.